So I can't factor anything until one side's equal to 0. So I move the 24 over. I need two numbers that multiply to 24, but add to 5. 8 and 3.
Doesn't have to be negative 24?
Okay, negative 24. Okay. Multiply to negative 24 and add to 5. Plus 8 minus 3. Those are my numbers. Now, keep going. X plus 8 equals 0. So one value of x is negative 8. And x minus 3 equals 0. The other value, x equals 3. I did make a mistake on the answer key. I thought I could reject negative 8, but you don't have to. Ready? Here's why. Here's why you don't want to reject negative 8. Okay, I know it's negative. That doesn't make a difference. But watch what happens when I plug it in here. Everyone see this square, this x squared plus 5x side? Okay, watch what happens when I plug in negative 8. Ready? Negative 8 squared minus 5 times negative 8. All I did was everywhere I saw an x, I plugged in negative 8. Everyone ready? Watch what I get for an answer. I shouldn't have got that. Why did I get that answer? Plus, what did I do? Oh, it should have been plus. One job. Let's try that again. Negative 8 squared plus 5 times negative 8. There we go. Do I get a negative side length? Do I get a negative side length? Anybody at home? Negative side length? No. In fact, I get 24, which was the other side length, which I should have because it was isosceles. So there was no reason for me to reject the negative 8 on the answer key. Those are two valid answers right there.
So if we were doing this on a test, but we only did negative 3, would it still be correct, or would you want us to add negative 8 as well?
Both are answers.
Okay.
So x equals negative 8 and 3. I would need for full credit. Yep.
Will we do something like this on the unit test, factoring?
I don't know. I'll have to take a look at the unit test. I don't know off the top of my head. Okay. All right. What else here, kids? Let's keep going here.
I have a similar question to Sophia's, but for 39, like how to set the equation.
Okay. So you see my diagram up here for 39. You see the two sides are equal.
Yeah.
Right? Two sides are equal. Actually, let me just try to maybe it easier if I can blow this up a little bit. Yeah. Okay. So for 39, the two sides are equal, which means what from our discussion on Wednesday? Not only the two sides are equal, but the two angles across. So you see how I put a 2y minus 5 there? I can also put it here because they're equal to each other. All three angles I know add up to what? 180. So let's see right now. I'm just going to cheat here. Y squared. I got 4y, right? And then negative 62, negative 5, negative 72 equals 180. We're all good there. Okay? Again, going back to Sophia's point, you see a y squared and a y. Same equation. Got to factor? Can't factor unless it's equal to what, though? 0. Move the 180 over. Y squared plus 4y minus 252 equals 0. All right, here we go. What am I looking for? Two numbers that do what? Add up to 4, but also at the same time multiply to negative 252. And I get it. Negative 252 is a large number. All right, you're going to have to play around for a while, but on your schedule, what type of geometry are you taking now? Honor, so I don't feel too bad. All right, that you got to play around and find two numbers that multiply to 252, but add up to 4 somehow. I don't feel that bad. And it ended up being 18 and 14, the numbers. 18 times 14 will give you 252. The 18's got to be positive, and the 14's got to be negative. So last step, y plus 18 equals 0. Y minus 14 equals 0. So you get y equals negative 18, and you get y equals positive 14. Everyone's still with me? Because this is different than the last problem. Watch what happens now. When I plug in negative 18 for y right here, anybody know what's going to happen? I don't even need the calculator. What's going to happen when I plug in negative 18 up there? Negative degree measure. And not this year anyway. Next year you can talk about that. But this year, can't have a negative angle measure. So that is why negative 18 will not be part of my solution set. It is getting rejected. So that's why 14 was the only, maybe do that again. 14 was the only acceptable solution. Okay? Everyone see that, how it got rejected. Why it got rejected, because that's on you if it's going to be on the test next week. Okay, anything else here we need to cover? Ask away. Anybody at home here before we call it a day? Because I'm going to be, as you guys can tell, when I look at your homework on Classroom later on today, I'm going to be looking for some serious algebra. I just went over 38 and 39, so all the work should be there. Factoring everything, just not final answers. Sure you guys at home don't need anything else? You guys here in class? Okay, you guys at home, clean it up, submit it. You guys here, I'm coming around. All right, what we're transitioning to today is taking our isosceles triangle from Tuesday and putting them in proofs now. So again, I just want to make sure we're all on the same page. Isosceles triangle, yes, two sides are equal, but so are what? Two angles. How do I locate two congruent angles? I look where? Across from the sides. Keep that in mind today. Keep that in mind. All right, I'm going to let you guys just go ahead. You guys know the deal. Set up, write in your givens, mark your diagram, and also might be beneficial now to highlight the two triangles I'm asking you to prove congruent, because you will see right now that they overlap each other. So go ahead, you guys at home, you guys in class, go ahead. Let's write in our givens, mark your diagram, highlight the triangles because they will overlap here. Okay, please slow me down here if we go too fast or you get lost. All right, first thing I need is, let's look at the givens, please. Everyone look at the two givens you were provided. What I want to know is, did I start you off with any sides in those triangles we're trying to prove? So I can put a little S next to them like I usually do in parentheses. So TR and TS, are those full sides in the two triangles I'm trying to prove congruent? It's just the yes or no here. Are TR and TS full sides? No, they are not in the triangles I'm trying to prove. Okay, what about the other givens? Is TM and TN? TM and TN. Are they full sides? No. What am I trying to tell you guys? I gave you nothing to start with. I didn't give you any sides or angles. You guys got to help me find all three pair right now. Okay? Use the givens to get there, but I did not give you any sides or angles to start from. Everyone home see that as well. I did not give you any sides or angles to start with. So you are on the hook for something right now. All right, you ready? Hopefully you have something in mind that you see. How can I get to a side or an angle? Well, actually, you know what? Before that, it's been a while. Let's review real quick. 5 methods of proving triangles congruent. Just so we remember what we can do and what we cannot do. Here we go. 5 people. Ready to roll? Boom. First one, Lucas, method. No. Give me one of the 5 methods to prove triangles congruent. I'm not even getting to the proof yet. 5 methods to prove triangles congruent. Which will give me just one. Side angle, side. Angle's got to be in the middle. Give me another method. Let's go 10. Atticus. 8. Whoa, HL. Good man. Everyone forgets about that one. How can I definitely tell already I'm not using HL? What type of triangle do you need for HL? Right triangle. I'm not getting a right triangle. So I know HL's out, but it is a method. Let's keep going. Might need it later on today. Oh, Anthony, what do you got for me, boss? Side. Yeah, can't forget about that one. That's our favorite, right? Easiest one. Boom. Everyone in here. Caroline, what's up? Yeah, if that side's in between, I can call it angle, side, angle. And if it's not in between, Caroline. There you go. All right, so there's all our options, everybody. We already said HL's out, but it's probably going to be one of the other 4. Get me a side or angle in your proof. Let's go back to the proof. How can you get a side or an angle now? All right, let's go home now. Owen, how can you get me a side or an angle here?
Angle NSR is congruent to angle MRS because they're opposite of the congruent lines.
Okay, you got the right thinking, Owen, but you gave me the wrong angles. Here you go, Owen. Let's go back. Name the isosceles triangle in this diagram, Owen. Name the isosceles triangle.
ESR.
TSR. So what I need you to give me, Owen, is full angles in TSR. Owen, see what you gave me? See that little angle I'm marking right now? That's not an angle in TSR. What's the full angle in TSR that's across from TR?
NSR.
There you go. So let's do this again. So let's go angle NSR is congruent to, name the other angle across from TS, Owen.
MRS.
There you go, boss. Everyone else see what he's doing right here. He's using our fact from Tuesday that says if the triangle's isosceles across from the congruent sides are congruent angles. Everyone see Owen do that? Yep. No. Because here you go, Quincy. You say that. You say angle R. I'm looking at 3 angles right now that could be angle R, right? The 2 smaller ones and the big one. So I need 3 letters in that case. All right, what's our reason going to be? We wrote it down a couple times on Tuesday. In a triangle. Congruent. What did I give you guys here? What did you know about the triangle? The sides or the angles were equal? Sides. So congruent. Sides are across from congruent angles. And really, Owen did us a favor because usually that's the last thing kids see is that pair of angles. So good job, Owen. Good job. Everyone see how we got to the angles because that's kind of the new part here today. Everything else is old school. All right? How else I'm going to get the sides here? Everything else is going back to Unit 2. What else do you see up here? What else can you get me? Let's go, Ryan. What else here? Come on, dig deep.
RS is congruent to RS.
I got a little shared side, don't I? All right, that's what usually kids give me first. Yep, I got shared side RS. Little reflexive, coming at you. There you go. You just gave us a pair of sides. I need one more pair now to finish this beast off. I got a side. I got an angle. Where's the other pair? Use all your givens. Use all your givens. We haven't even talked why they gave us TR, side TR, or side TM, congruent to side TN. They gave it to us for a reason. Come on now, let's dig deep. That was still Ryan. Sorry, I didn't click it yet. There we go. Let's go, Anthony. What else do you see up here, boss?
TR minus TM is congruent to TS minus TN.
Good. We're going to get, everyone take a look at your diagram. We're going to get side MR congruent to NS by subtraction. All right, by subtraction. We're going to take TR and we're going to subtract TM from it. That's why they gave us TM in the givens. And we know that's going to be congruent to if we subtracted TS and TN from each other. Told you, old school stuff. Subtraction. And what unit are we in for? Still not changing. What comes after subtraction? Substitution to say the actual sides, MR and NS are congruent. And there is another pair of sides. So I don't even have to ask people. I have two sides and an angle. It's gotta be, as long as that angle's in between. Triangle RMS congruent to triangle RNS. 6 steps. What's the method? Finish this off, please. Icing on the cake now. 1, Vinny, what method?
Side angle side.
There we go. SAS, side angle side. How do we feel on that one? What's the new part? We knew the triangle was isosceles, so we knew the angles across had to be equal. That's the new part. Everything else is review, isn't it? Subtraction, substitution, reflexive, all review. Questions? Anybody at home want to ask anything? Yes?
Wouldn't it be SNR because
RMS and RNS. What's the problem?
don't they have to like match it?
Oh, it has SNR on our sheet. Yeah, ours is.
What? I'm sorry, I have the wrong one up here still.
I don't know.
RMS is congruent to SNR, that's what.
SNR, you guys have? Okay, yeah, that's my fault. Okay. Anything else, guys? Okay, you're still hungry. Let's go. You're not even close to fed. Set them up. Here you go. Set them up. These two triangles I'm asking you to prove congruent also overlap each other. They also overlap, kids at home. So if you want to do a little highlighting, go right ahead. I don't know, but I'm hoping you guys are seeing these proofs are starting to increase in difficulty very quickly from the ones you had on your quiz. Which, by the way, is, I don't know if anybody's taken a look. You can go on formative and see it now. What you got right, what you got wrong. Everyone's taken it. So I released it last night, I believe. So you can go on and see what you got right or wrong. Okay, take a look. First, take a look at your givens. Do you know any full sides there? Did I provide any full sides? If I did, name them. All right, that's what I need from somebody right now is, in the givens, did I provide you with a full pair of sides? If your answer is yes, tell me which pair up here are the sides that I gave you. Emily, did I give you a full pair of sides in the givens?
Yeah.
Which pair?
A, E, and E, D.
Great job, Emily. Great job. So I'm going to put an S there. So you guys got a full pair of sides from it. The other pair, A, B, and C, D, they're not full pairs, so I'm not going to put an S next to them. So you guys are on the hook. Help me get 2 other pair of equal parts. Help me get 2 more pair of equal parts. Okay, I'll check on it in a second, Maeve. Give me 2 pair of equal parts here. You know we're equal. How you getting to them? Radhika, go ahead. Give me a pair.
You can say that angle EAD is congruent to EDC because of like in a triangle, congruent sides are across from congruent angles.
Everyone see that? The whole triangle is isosceles, so not only are those 2 sides, but the angles across. And Quincy, going back to your question earlier, if you want to go A and D here, now that's okay. Okay, because there's no other angles coming from it. So angle A congruent to angle D in a triangle. congruent sides are across from congruent angles. Good job. So Radhika just gave us a pair of angles. So I need help from somebody finding one more pair here. One more pair of something. I got the sides. I got the angles. Remember, givens are provided for a reason. Nobody has mentioned why they gave us AB congruent to CD yet. Right? They gave it to us for a reason, to use it. Where else are we going from here? Emma, going deep. See anything else, Emma?
Well, we can say, well, subtraction for like B, C. I know what I'm trying to say, I just can't like say it.
Okay, so AB and CD aren't going to help you out, right? They're not full sides, right?
Yeah,
Okay, so AB's got to turn into AC somehow because that's the full side on one of the triangles, right? AB's got to be extended out to AC. So what must I do to AB to make it look like AC?
add BC,
Okay, and then on the other triangle, what do I have to do to DC to make it look like DB?
add BC. again.
Okay, so both times you're adding what, Emma?
BC.
There you go. So this is going to be addition, but before I add, I have to tell you BC congruent to itself because you need two equal quantities to add. So reflexive, and then if you just heard the discussion between Emma and myself, take side AB, add it to BC, and that'll be the same length as if I took CD and added it to BC. So now you got addition in this proof, followed by substitution to say AC is congruent to BD. And there it is, guys. There is our side. Just take a quick peek. I know you have SAS. That automatically doesn't equal side angle side. You got to take a peek. Is that angle in between? Yes, it is. Thank you. So yes, it is side angle side. What do I have here? Triangle AEC. Anything else you guys want to ask on that one? How are we feeling here? All right? You just keep in your mind, you have this fact about isosceles triangles that yes, the sides are equal. And are you okay getting the angles? Because some people struggle with maybe finding where those angles are. Everyone all right while we marked A and D? Okay. I'm going to flip the script on you now. Flip the script. In the last two proofs, you knew it was isosceles. In this next proof, tell me why it's isosceles. Tell me why it's isosceles. Okay, before we even start sniffing this proof, I have a general question for you. If you're going to tell me that a triangle is isosceles, what do you see on the diagram? If you're going to tell me it, if you're going to say, Mr. Carlino, that triangle is isosceles, why would you say that? Because you see what about the diagram? Okay, I could see two sides are equal. If I see that, it's isosceles. Keep going. You might see two sides or you might see two angles. So this is what you need. You need one of these right now to prove triangle ABC is isosceles. You do not need both. You do not need both. Show me a pair of angles are equal or show me a pair of sides are equal. You got isosceles. You do not need to do both. Either get me two sides or two angles equal. And I'm starting you off by saying 3 is congruent to 4. Those are not the two angles I need congruent. They have to be inside the darn triangle. Come on. They got to be inside. All right. That's all I'm giving you. And yes, this is previous theorems we're going to be working with. How do I get 3 and 4 inside? How am I going to get 3 and 4 inside? Any thoughts? Or you know the theorem maybe we're going to use here? Sophia?
I know you can say that 1 and 3 and 2, 4 are supplementary pairs. I don't remember the wording for the reason though.
Okay. Yes, we're going to be using supplementary angles here. All right. And if you're going to be using supplementary angles, Sophia just said in class, you need to tell me what angles are supplementary. And she said that angle 1 and angle 3 are supplementary. Also, angle 2 and angle 4 are supplementary. And from here on out, you're going to tell me why the same way. Why angles are supplementary. Anybody remember? Used to be a theorem we had up on the board. I believe it was in pink. Linear pairs are supplementary. This is always probably going to be your reason why you tell me angles are supplementary. Linear pairs are supplementary. Where are you guys going here? Remember, I need congruent angles. I don't need supplementary angles. Where are we going? Okay, now you can tell me 1 is congruent to 2. Because if 3 and 4 are congruent, so are their supplements, 1 and 2. Remember the theorem, supplements, still not with an I, with an E. Supplements of congruent angles are congruent. Do you have 2 congruent angles? Okay, you guys don't need to go to, I see a lot of always go to the sides. You can do that, that's fine. You don't need to tell me the sides are equal. We're good. This bad boy is isosceles now that 1 and 2 are equal. It's just what's the reason why it's isosceles, right? So triangle ABC is isosceles. You guys, in your own words, why is it isosceles? You have 2 congruent angles. That's fine with me. Ready? 2 congruent angles implies isosceles triangle. Fine with me. I don't need anything fancy. Yep.
I just said angle 1 is congruent to angle 2.
That's fine too. Yep. Just do not give me definition of isosceles triangle. You guys know how I feel about telling me it's something by definition of it.
So if that's the phrasing for the answer, it doesn't matter where the placement of the angles are. Like, let's say there's angle 1 and angle A.
Does it have 2 congruent angles? It's isosceles. Okay. I don't care where they are. Remember we talked on Tuesday, so it doesn't have to be the bottom ones. If you have 2 angles congruent in a triangle, it's automatically isosceles.
And
Okay.
I know you said that we should never base it off of visual appearance.
Correct.
But most of the times, will it like appear like an isosceles triangle, even if it is split? Like, that's how I base it. If it's like, if I think that something isn't, if I'm unsure of something, that's probably one might tip off.
Never go by the drawing. Okay. Always go by your knowledge. Okay. Any other questions there? Because no more holding hands. You guys are on your own for the last one. And it's pretty diesel, beefy, meaty, hardcore, swole. Add in your own word there. Okay. No joke. Beastly. Catching my drift here? Let me get you started with it. Can you add to your givens? Everyone sees where it says HJM is isosceles. Can you guys put with JH congruent to HM? I know it's marked on your diagram, but it should have been in your givens that those 2 are the congruent sides in that isosceles triangle. Okay, with JH congruent to JM. And the last thing before I leave you to do it on your own, look at the proof statement. You're proving a pair of angles. Angles congruent. How do you think this proof's going to end? With what your reasons? If I ask you for 2 corresponding angles. CPCTC, yeah. So can you guys, before you start, can you figure out the 2 triangles you're going to need to prove congruent that contain those 2 angles? What 2 triangles contain those 2 angles? These 2 outside ones on the left and on the right. You can get those congruent. You can say CP, but you got some work to do to get them congruent. And I'll let you guys work right up to the bell here. You guys at home, same thing. You got about 6 minutes here to work on it, which is plenty of time. And I just want to remind everyone, side angle is not a way. Because some of you guys may end up with side angle, but it's not good enough.
When you're trying to use reasoning for an equilateral triangle, would you need to say something like all sides or something like all angles in the equilateral triangle are congruent instead of definition?
That's fine. Yeah, I'm totally all right with that. Yeah. And that's a good, Sophia may have just given some of you a hint. If it says it's equilateral, that means more than the sides are equal, so are the angles. Maeve, you want to give it a try now? Let me know. Maybe I just put on the wrong settings. Really? Well, I don't know what I'm doing wrong then. I'll figure it out today though. Try it again one last time, Maeve. Try to refresh, see if you can see anything different. You see it now? Oh, guy's a genius. There we go. So we're good now. So quiz officially open. Keep going with this, up to the bell, keep going, because I am going to go over different ways to do this one tomorrow as part of the homework. And I believe, make sure you guys realize homework is now in the packet, not out of the textbook anymore, out of the packet. So I will put a copy of those pages on Classroom today if you want to do it that way. Yep, go ahead, Radhika. What do you got for me?
So if it tells you a certain triangle is isosceles,
Yep, they
and it
should,
tells you with which side,
yes,
is that side considered like, can you say that like those are sides, like congruent?
yeah,
Or adjacent?
yep, yes.
Okay.
Yeah, in the rest of the proofs we do, if they say a triangle's isosceles, they should be telling you which 2 out of the 3 sides are the equal ones.
If you wanna say angle K is congruent to angle L, can you just say
Ooh, I don't like K and L. I have no idea what you're talking about. There's a couple angle Ks and a couple angle Ls. So you better go through
HKL
that.
and HLK.
Definition of equilateral. That's fine.
Alright,
Equilateral triangle, all angles are equal. I'm fine with those. All right, you guys behave. Have a great day. You guys at home. I'll see you tomorrow. You too. Thank you.
Wait for me. I got to meet consultants.
I don't want to